Hello viewers, in this lecture we will discuss how to convert a given binary number into an equivalent decimal number and a given decimal number into an equivalent binary number. First, we will discuss how to convert a given binary number into an equivalent decimal number. To convert a given binary number into an equivalent decimal number, we have to proceed following the steps. Step 1. First we will write a given binary number. Step 2. Now we assign weight 2 raised to the power n to each bit of the number from right to left, starting from n equals to 0. Step 3. The sum of product of each bit with their corresponding weights of all bits gives the equivalent decimal number. To make this concept more clear, we will discuss some examples. First example is, we have to convert the given binary number into an equivalent decimal number. First, we will write a given binary number. Now, we will assign weight to each bit of the number. Now, sum of product of each bit with their corresponding weight gives an equivalent decimal number. Now we will discuss next example. In this example, we have only fractional part because left hand side of the binary point is 0. This form is also known as binary fraction form. To convert a binary fraction form into an equivalent decimal form, we have to proceed following the steps. Step 1, we will write binary number. Step 2 is, now we assign weight 2 raised to the power n to each bit of the number after the binary point from left to right, starting from n equals to -1. Step 3, the sum of product of each bit with their corresponding weight of all bits gives the equivalent decimal number. Now we will discuss next example. Here we have a mixed binary problem. So first we will write a given binary number and then we will assign weight to each bit of the binary number as we did in the previous questions. Now we will calculate sum of product of each bit with their corresponding weights and then we will get an equivalent decimal number of the given binary number. Now we will learn how to convert a decimal number into an equivalent binary number. The most common method to convert decimal number to an equivalent binary number is successive division method. Before going to start this method, we should remember some important terms which we are going to discuss. Suppose we want to divide 38 by 3. So here 38 is a dividend and 3 is a divisor. Now we know that 3 multiplied 12 equals to 36. So here 12 is a quotient which we will write below the dividend 38. Now difference of 38 and 36 is 2, which is remainder. If we again divide 12 by 3, then 12 becomes dividend and 3 becomes divisor. Now 3 multiplied by 4 equals to 12. So here 4 is quotient which we write below the dividend 12. Now the difference of 12 and 12 is 0, which is a remainder. Now we will discuss successive division method. First, in this method we divide the decimal number by 2 because the base of the binary number system is 2. Second, the quotient becomes a new number to divide again. Third, the remainder will be always 0 or 1. Fourth, division continue until the quotient is 0. Fifth, first remainder will be called least significant bit. Sixth, last remainder will always be 1 and it will be called most significant bit. Seventh, now binary number corresponding to the given decimal number is obtained by assembling the remainders in reverse order. It should be remembered that binary number system has two digits 0 and 1. So remainder will always be 0 or 1, which becomes the 1 bit of the binary number. Now we will clear this method with an example. Here we have to convert a given decimal number into an equivalent binary number. Now we divide the given decimal number by 2 and we write the quotient below the dividend, that is 167. On dividing, we get 83 as a quotient and remainder is 1, which becomes the least significant bit. Now 83 acts as a dividend and we divide 83 by 2 and we get 41 as a quotient, which we write below the dividend 83 and remainder is 1. Again we divide 41 by 2 and we get 20 as a quotient and 1 as a remainder. We have to proceed until we will not get quotient 0. And the last remainder will be the most significant bit. Now, the binary number corresponding to the given decimal number is obtained by writing the remainders in reverse order. That is, we have write R8 as a first and R1 as a last remainder. So, the resultant binary number corresponding to the given decimal number is. Now, we will learn how to convert a decimal fraction into a corresponding binary fraction. To convert a decimal fraction to binary fraction, we used successive multiplication method. In successive multiplication method, we have to follow these steps. First, multiply only fraction part by 2 and record the integral part. Integral part will be either 0 or 1. For example, in 32.658, here 32 is integral part and 658 is fractional part. So, we have to remember that we have to multiply only fractional part. Second, again multiplying the remaining fractional part by 2. Here, we will not use integral part in multiplication. Third, continue until the fractional part becomes 0 or up to required number of digits. Fourth, the integral part of first multiplication will be written first and then of second multiplication and so on. To clear this concept, let us consider a decimal fraction which we have to convert into a equivalent binary fraction. In this question, we have to multiply 0.8125 by 2. Here, the integral part is 0 and the fractional part is 8125. On multiplication, we get, here 1 is an integral part. Now, we have to multiply again the fractional part, that is 6250 by 2, and on multiplication we get, here 1 is an integral part and the fractional part becomes 2500. Again multiply the fractional part by 2 and we get, here 0 is an integral part. Now we multiply the fractional part by 2 and we get 1 as an integral part and the fractional part becomes 0. So, the binary fraction corresponding to the given decimal fraction is. Now, we will discuss next example. Here, we have to convert a decimal fraction into a corresponding binary fraction. As we did in the previous example, we have to multiply only the fractional part by 2. So, on multiplying, we get 0 as an integral part and 66 as a fractional part. And proceeding in the same way, we get In this question, we have to remember these points. If we continue in the same way, the fractional part will never become 0, conversion will not be exact, and we will get an approximate binary number. To get more closer approximation, in this case, we have to move to more binary bits. If number of bits are not specified in the question, then it is better that we move up to 6 bits. So, the binary equivalent of the given decimal fraction is, here in this example, number of bits is not specified, so we are calculating up to 6 bits. In this case, binary conversion is an approximation of given decimal number. Now, we check it by converting this 6-bit binary fraction into an equivalent decimal fraction, and on converting, we get which is approximately equals to the given decimal number. So, to get more and more closer approximation, you can calculate more than 6 binary bits. Now we will discuss next example. Here we have a mixed decimal number. 38 is an integral part and 6 to 5 is a fractional part. First we have to convert an integral part into a corresponding binary number as we did in the previous example. Now we convert the fractional part into a corresponding binary number as we did in the previous example. Now we combine the result of both integral part and fractional part. Result of integral part is placed before binary point and the result of fractional part is placed after the binary point, and we get the corresponding equivalent binary number to a given decimal number. I hope this lecture was helpful to you. If you have any problem, any query or any suggestion, please write in comment box.